All right, you guys, so in the previous video, we learned how to convert numbers that were written in scientific notation to standard notation, and we also looked at how to do the reverse. So if they were in standard notation, how to write them in scientific notation. So now what we're going to do, we're going to look at arithmetic operations with scientific notation. So what that means, we're going to learn how to add and subtract, multiply and divide numbers that are written in scientific notation. Okay, so the first scenario that we're going to look at is adding and subtracting numbers that are written in scientific notation. So in order to add and subtract numbers in scientific notation, the exponents must be the same. Okay, that's important. The exponents have to be the same. So remember, if your numbers are in scientific notation, they look like n times 10 to the p. This means if you're adding and subtracting, this exponent has to be the same before you can do that. Once the exponents are the same, you can keep the exponents and add and subtract the numbers. Okay. All right, the next scenario we're going to look at is if we are multiplying numbers that are written in scientific notation. If you are multiplying numbers in scientific notation, the exponents do not need to be the same, okay? They do not have to be the same. So what you're going to do is you're going to multiply the numbers together and you're going to add the exponents, okay? Same thing with division. If you are dividing numbers that are written in scientific notation, the exponents do not have to be the same. All you need to do is divide the numbers, and then you're going to subtract the exponents, okay? So the only one you need to be super careful for is adding and subtracting, because their exponents have to be the same before you do either of those operations, okay? So let's take a look at some example problems. All right, so in these first problems, they want us to perform the indicated operation. So in A, they have 2.3 times 10 to the third power plus 1.65 times 10 to the fourth power, okay? So when you're doing these problems, the first thing I want you to do to get in the habit of doing is looking at the operation, because you're gonna get to a point where they're all gonna be mixed up. So you need to look at the operation first. So as I'm looking between these two scientific numbers, all right, I see a plus. That means for this problem, I'm using addition, okay? So from our rules, if we are adding numbers that are written in scientific notation, their powers have to be the same, okay? Okay, so as I'm looking at this problem, when I look at their powers, okay, the power on the first number that's in scientific notation is 3. The power that's on the second number is 4, okay? So before I can even begin to add or subtract, their exponents have to be the same, which means that I need to convert either the first number or the second number so that their powers match, okay? So if I need to do that, one thing I want you guys to keep in mind, okay? So if you need to fix the powers, okay? If you need to move the decimal, okay, to the left, it's the same thing as adding 1 to the power when you're doing that. That's one way you can think about it. If you need to move the decimal to the right, then it's going to be the same thing as subtracting 1 from the power. So if you keep that in mind, you'll help yourself when you're solving these problems. All right, so it does not matter which one you fix, okay? So let's see. I guess I'll fix the first one. Doesn't matter. All right, so if I'm going to fix the first one, what I mean by fix is that since its exponent is 3, I need it to match the second number, who is 4. So that means I need to turn this exponent of a 3 into a 4. So if I'm looking over here at my rules, okay, in order for 3 to become 4, I need to add 1. So that means I need to move this decimal to the left, okay? And however many times you move it, it's the same thing as if you were adding that many or subtracting that many from the exponent. So I'm going to move this decimal to the left 1, because 3 plus 1 is 4. So that's going to give me 0.23 times 10 to the fourth power plus, I'm going to write another number, 1.65 times 10 to the fourth, okay? Now that their exponents are the same, I can combine their number parts, okay? So I'm going to use the operation that's in this problem, which is addition. So I'm going to add 0.23 plus 1.65. So that's going to give me 1.88. And you're going to keep the exponential part. So times 10 to the 4th power. Okay. And that's going to be your solution. All right. Let's look at the second one. So in the second problem, they want us to subtract these two numbers that are written in scientific notation. So once again, you need to look at the operation first, because remember, they're going to mix these problems up. So the operation that's here is subtraction by the minus sign. So for subtraction, it's the same rules as with addition. You're going traction. Let's write it the right way. Let's move this up. All right, so for subtraction, same deal. You need the powers to be the same before you do the operation. So if I look at my exponents, just like I did in the last problem, the exponent on the first number is 3. The exponent on the second number is 2. So you need to fix one of them so that their exponent parts are the same. Doesn't matter which one you fix, totally up to you. All right, let's say we want to fix, I don't know, the second one this time, since we did the first one. Let's change our pin color. All right, so if I change the second one, okay, then I need to make this 2 a 3. So in order to make 2 become 3, you need to add 1, which means that I need to move the decimal to the left, okay? So I'm going to take this decimal, I'm going to move it to the left. So that's going to give me 5.7 minus 0.49 times 10 to the 3rd. Okay, so now their exponent parts are the same. I can subtract their number parts. Okay, so I'm going to have 5.7 minus 0.49. So that's 5.21 times 10 to the 3rd. Okay. All right, so be careful. If you're adding and subtracting, you keep the number part. You need the exponent part to be the same, and then you can do the operation on the numbers. Okay? All right, let's try. Let's check ourselves. Let's see if we're right. Yep, 1.88 times 10 to the 4th for A, and 5.21 times 10 to the 3rd for the second one. Cool. All right, moving right along. All right, so let's look at these. All right, so it says perform the indicated operation again. So for A, we have 6 times 10 to the 3rd power times 3 times 10 to the 5th power. So once again, remember, you need to look at the operation that's in your problem. So for the first one, the operation that we've been given is multiplication, okay? Okay, and per our rules for multiplication, the exponents don't need to be the same. So the powers don't have to be the same. Okay, all right, so since they don't have to be the same, it said to multiply the number parts and then to use the laws of exponents to convert them. All right, so let me remind you. So if you are multiplying, okay, all right, so if you are multiplying like bases, you add their powers. Okay, so if you have anything that looks like x to the n times x to the m, you add the powers together. Okay, all right, even though we haven't done it yet, let's go ahead and write the rule for division. All right, so if you are dividing, then if you have like bases, you subtract the powers. So if you have anything that looks like that, it's x n minus m, okay? So keep those laws in your head when you're doing these problems. All right, let's change my pen color again. All right, so we're doing multiplication. So I'm going to multiply their number parts together. So that's 6 times 3. 6 times 3 is 18 times 10. Since I was multiplying, I add their powers. So I'm going to add 3 plus 5. So that's 8. All right. Now, your answers must always be in scientific notation. So remember, a number that's written in scientific notation is in this form, n times 10 to the p power, okay? And remember, n has to be a number that's between 1 and 10, okay? So when we're looking at 18 times 10 to the 8th power, 18 is bigger than 10, which means that you're going to have to adjust this answer, all right? So it's understood that the decimal is in the back of this number, okay? And you need to move the decimal in such a way that when you move it, that number that results falls between 1 and 10. So I'm going to move this decimal one place to the left, okay? When I do that, remember, anytime you're moving the decimal to the left, it's like you're adding 1 to the power. So my final answer is 1.8 times 10 to the 9th power, okay? All right, let's try the second one. All right, so for the second one, we're doing division, okay? All right, so for the same thing with division, you don't care if the powers are not the same. All right, you're going to use the laws of exponents to fix your answer. So the first thing we're going to do is we're going to divide their number parts, okay? So we have 15 over 6. 15 over 6 reduces to 3 over 2, which as a decimal would be 1.5. Okay. And then because you're doing division, you're going to subtract their powers. Okay. You're going to use your laws of exponents. So 6 minus 4, all right, is 2. So times 10 to the second power. And then just like the one before, you need to make sure that your final answer is also written in scientific notation. So the n would have to be a number that falls between 1 and 10. When we look at it, we're good. 1.5 does fall between 1 and 10, and we have times 10 to the second power. All right, cool. Let's check ourselves. Let's see if we're right. Yep, 1.8 times 10 to the 9th, and 2.5. Let's see. Oh, yep, I'm tripping. All right, that is 2.5. 15 is divisible by 3. Oh, it's 5. Sorry, guys. This is a 5. It's all right. Teachers make mistakes too. 5 divided by 2 is 2.5. There we go. 2.5 times 10 to the second power. Cool. All right. Let's scroll up. All right, let's see if we can do these, okay? So if you guys want to pause the video now and to see if you guys can do these by yourself, see if you can do that, all right? And then come back and watch me how to do it, all right? So let's see. The first thing we're going to do is check our operation. In this problem, we are adding, which means that our powers need to be the same before we start. So it doesn't matter which one I fix, okay? Let's say I fix the second one. So if I look at my exponents, the exponent on the first one is -3. Exponent on the second one is -4. So I'm going to fix the second number. So the decimal is understood to be here. I want to change -4 to -3. So that means I want to add 1 to it, which means I'm going to move the decimal to the left here. So that's going to give me 15 times 10 to the -3 plus 1.8 times 10 to the -3. And then I'm going to add their number parts together. So 15 plus 1.8, that's going to give me 16.8 times 10 to the -3. And remember, your answer must always be written in scientific notation. So 16.8 is a number that's bigger than 10. So I need to adjust the decimal. So in order for me to do that, I'm going to have to move the decimal to the left one place. When I do that, anytime you're moving the decimal to the left, you are increasing the power by 1. So my final answer is going to be 1.68 times 10 to the -2nd power, okay? So be careful when they're negative exponents. When you add 1 to -3, it's not -4, it's -2, okay? All right, let's try the second one. So for the second one, we are doing multiplication. For multiplication, you don't care if the powers are the same. So you're going to go ahead and multiply their number parts. So we're going to do 19 times 21. That's 399 times 10. Because we are multiplying, we are going to add their powers. So -2 plus -5, which is going to give us -7. Okay, so it's -7. Remember, your answer has to be written in scientific notation. So 399 is definitely a number that's bigger than 10. So we're going to have to move the decimal. And I'm going to move the decimal 1, 2 places. So that's going to be the same thing as adding 2 to that power. So my final answer is 3.99 times 10 to the -5th power. Cool. All right, let's see if we're right. Let's see, 1.6 times 10 and -7. Did we get -5? We did. All right. So now you guys know how to add, subtract, multiply, and divide numbers that are in scientific notation. All right, cool.